Today, we're going to talk about basically quantum mechanics or modern physics in a nutshell. We're going to try to go over this in about 20 minutes. We'll see how far we get. If we need more time afterwards, I am not going to use this class time. If I need to, I'll use next period. I won't be using the rest of this class period. You guys should have at least 20 minutes to get stuff done. Okay? So let's start talking about quantum mechanics. The first thing you need to know is what's called black body radiation. Okay? Now, when we talk about a black bodies are matter or mass that absorbs and re-emits all light that comes in on it. So you can take an object and you can say, all right, it's sitting out there in space. It gets struck by light. It absorbs all the light that strikes it and re-emits that light. Now, there are things in the universe that absorb and re-emit light. Just about anything that has matter does that, but not to the point that we suspect of the black body. They don't absorb 100% and they don't re-emit 100%. Okay? Yeah.
So they don't absorb 100% of the light, and then they don't re-emit 100% of what they collected.
Exactly.
Okay.
Exactly. So if you took an object and it experiences a certain amount of energy, let's say 20 joules of energy from light, and it'll only absorb maybe 19, and maybe only re-emit 18 back into the universe. Okay? Does that make sense? Yeah.
Are you saying that there's nothing that is pure black body radiation?
The idea of a perfect black body doesn't really exist.
What's the closest thing that we have to it that is?
I mean, that's a tough question. Maybe some certain celestial bodies they've known have. You could talk about dark matter possibly being a perfect black body. The reason why it's called a black body is because you can't see it. It'll be struck with light, and it re-emits the same light back out. So it itself doesn't leave a trace of its existence. So perfect black bodies would be something that experiences all this light and then re-emits it back out. So all you're seeing is the exact light coming in and coming out. It doesn't leave a trace. Like, take the Earth, for example. It's a nice big blue sphere, right? It's getting struck by all of this sunlight. Now, what color typically do we think of sunlight? Yellow. So if the Earth is a perfect black body, it would take in all that yellow light and re-emit all that yellow light. But it doesn't do that. We look at the Earth, and it is the Earth. It emits blue light, green light, all this other white light, if you will. So it's not a black body. Perfect black bodies, I'm trying to think of an example of a perfect black body, because I can't think of something that absorbs and re-emits light like that.
Yeah.
That's a difficult question. Give me a second to think about it.
Okay.
Because I would think some of your more exotic forms of matter would be better forms of black body than less exotic. Like dark matter is really exotic.
Right, but I don't understand how that is re-emitting it.
It would. I mean, certain forms of dark matter are weak. They're called WIMPs. They're weak interaction. So they don't really work very well with the rest of the universe. But there are possibility dark matters that are absorbing, re-emitting, so that you can't see. It's just another possible way. Like I said, let me think about perfect black bodies. That was a difficult one to think of. And there may be a reason for that. Thinking of quantum mechanics, there may be a reason that we're not experiencing perfect black bodies. So give me a second to think about it. Anyway, so that's black body radiation. You're dealing with an object that absorbs light and re-emits back the same light. Okay? And it's a theoretical construct. It's something that really doesn't exist in nature. Cool? So what we suggested with black body radiation is that if you take an object and you dump a lot of energy into it, that object's going to heat up. Yes? We know that thermally, that when you dump a lot of energy into a system, that object is going to tend to heat up until it goes to a phase change. But let's not worry about phase change. Let's just say it's going to start to heat up. What happens when we take a dark object and we start heating it up?
It gets lighter in color.
It gets lighter in color, right? It gets lighter and lighter and lighter and lighter. You take a piece of iron, which is really, really dark, you start heating it up. It starts getting red hot, and it starts getting lighter. Now, what we believed was going to happen is if you continue to dump energy into iron, we expect the color to get lighter, 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 and lighter, and lighter. Okay? As a matter of fact, traditionally, we believed that if you kept dumping enough energy into iron and it wouldn't melt, that it would eventually shift into the ultraviolet. That all the light that that piece of iron would generate would be ultraviolet light. Now, how many of you are in the habit of seeing ultraviolet light? Eric is the only one. There are actually species on the planet that can see in the ultraviolet range. But the idea is, oh, let's take a tank or a submarine, heat that baby up, it turns invisible. It literally would turn invisible if that's true. Shifting to the ultraviolet makes it not visible to our eyes. Okay? So we thought, oh, this is a great thing to explore. Let's start exploring.